As you read 5.2 and complete your guided notes, there are 4 main learning objectives. Identify factors affecting carrying capacity. Identify limiting factors that depend on population density. Identify limiting factors that do not depend on population density. And explain the relationship between limiting factors and population extinction. 2 vocabulary words that we're now going to go over are limiting factor, which is a factor that causes population growth to decrease, and density-dependent limiting factor, which is a limiting factor that depends on the population density. The growth of primary producers can be controlled by a limiting nutrient. A limiting nutrient is one example of a limiting factor. A limiting factor is any factor that controls the growth of a population. Limiting factors are biotic or abiotic environmental factors that affect members of a population. Acting separately or together, limiting factors determine the carrying capacity of an environment for a species. Limiting factors produce the pressures of natural selection at the heart of Charles Darwin's evolutionary theory. Limiting factors that affect a population most strongly when population density reaches a certain level are called density-dependent limiting factors. Such factors do not strongly affect small, scattered populations. Density-dependent limiting factors include competition, stress from overcrowding, parasitism, disease, predation, and herbivory. When populations are crowded, individuals compete for food, water, space, sunlight, and other resources that may be limited. Some individuals may have enough resources to survive and reproduce. Some may have enough to survive, but not to reproduce. Others may die from lack of resources. Competition for resources can decrease birth rates, increase death rates, or both. Competition is density dependent because resources can be used up when there are more individuals. Competition can be between members of the same species or between species. Parasites and disease-causing organisms weaken their host and can cause death. Parasitism and disease are density-dependent factors because they spread from one host to another more easily when populations are dense. Some organisms fight each other if they are overcrowded. Individuals can be weakened and may die. In some species, overcrowding stress can cause animals to neglect or kill their own offspring. Overcrowding stress can lower birth rates, raise death rates, or increase immigration. Predation and herbivory. The effects of predators on prey or herbivores on plants are density dependent. Population of predators and prey may rise and fall. When there is plenty of prey, the predator has plenty to eat and may increase in number. This causes the prey death rate to rise higher than its birth rate, so the prey population decreases. As the prey decreases, the predators begin to starve, so the predator population falls. This allows the prey population to start rising again. An herbivore is a predator of a plant. Populations of herbivores and plants cycle up and down, just like populations of predator and prey. Human activity may limit populations of other organisms. Hunting is one way that humans can cause large decreases in animal populations. Density-independent limiting factors are factors that affect all populations in similar ways, regardless of the population density. Density-independent limiting factors affect population regardless of population size and density. Environmental extremes, including weather extremes such as hurricanes, droughts, or floods, and natural disasters such as wildfires, can act as density-independent limiting factors. Such factors may cause a population to crash or reach very small sizes. After a crash, a population may increase again or stay low for a long time. Extreme hot and cold weather and severe drought, along with human-caused environmental damage, can affect populations of plants and animals. Limiting factors such as temperature and rainfall can change over time. Human activity can divide natural environments into smaller pieces, reducing available space and carrying capacity. If carrying capacity falls low enough, populations can be wiped out, leading to species extinction, and an extinct species has no members remaining.